Hello and welcome back to Math with Mrs. Becker. Today we are looking at calculus, the second part of chapter 1, section 4, where we are studying the new idea called a limit. Now, one way that you can look at a limit is by using this awesome derivative formula. Remember, we saw this in chapter 0 when we worked with functions. Then they showed us how we could go ahead and use this to find the derivative of a secant line. Remember, we had the points P and Q, and H represented the horizontal distance. And as the 2 points got closer and closer together, as H approached 0, what happened is you got closer and closer to the derivative, which is the slope of the tangent line. Okay? You can also use this formula to go ahead and calculate a limit. So this says using limits to calculate a derivative. So again, step 1, you go ahead and do the quotient formula. Now notice that here we have x's. That's what's going to change here. Simplify the difference quotient, meaning go ahead and divide out the h. Then, as your horizontal distance approaches 0, for some value. Okay, so it's the same idea, but they're going to throw in numbers. So if I look at the first one, they want us to figure out what the derivative is for an x value of 5. So what I do is they replaced their x value with a 5. So I go ahead, and this is the formula. F of x is really a 5 plus h minus f of 5 over h. So this 5 replaces the x's in the formula. So let's go ahead and do this. So I rewrite the first function. I replace all of the x's with 5 plus h. So it's 15 minus 5 plus h quantity squared. That's this first piece. Minus, now remember this is more than one term, so it's 15 minus, where the x is, you fill in a 5 squared. And again, that's all over h, but let's go ahead and simplify the top first. Order of operations, I have to go ahead and square this. This means 5 plus h 2 times. So it's 15 minus the group. 5 times 5 is 25. 5 times h is 5h. h times 5 is also 5h. 5h and 5h make 10h. h plus h is h squared. Minus, now you guys check this out, 15 minus 25. If I take 15 and I minus 25, I get a negative 10. There are no h's here because I replaced the x with a value of 5, which is kind of cool. Let's go ahead and keep going. This negative goes to everything. So it's 15 minus 25 minus 10h minus h squared. If you minus a negative, this becomes a positive 10. Combine the like terms, and although you don't have to put it in standard form, I just want to go ahead and do that because I notice I have h's with squareds, I have h's, I have 3 constants. So just to kind of organize it in my mind, I'm going to go ahead and go standard form. So negative h squared minus 10h. Now if I take 15 minus 25 plus 10, well, 15 minus 25, that's negative 10. Negative 10 plus 10 is 0, so these things cancel. If I go ahead and divide it by h, that's what I would get. Negative h divided, or h squared divided by h. If I have 2 and I remove 1, I'm down to 1. Minus 10. So this is the formula. We're saying that the horizontal distance from 5 coming in on the left and the right is 0. So negative 0 minus 10, there's no such thing as a negative 0. Okay, so that's the same thing as 0 minus 10 equals negative 10. Now check this out. This is kind of cool, you guys. So one way to check it, I can go ahead and use the power rule. The derivative of 15 is 0. This 2 would come out front and be multiplied by the negative 1, so it'd be negative 2x. I had 2. If you reduce the exponent, now it's only 1. Take the derivative, fill in a 5. Negative 2 times 5 is a negative 10, so yes, we got the same answer. This is a really cool thing. When you create something new in mathematics, you can't just figure out one way and say, hey, this is how it is. And so what we're seeing right now is that what we're doing is figuring out a limit, but we're using derivatives, and we can do this multiple ways. They call this the 3-step or the secant method. That works. You can do the power rule. That works. So it's really cool to be able to see that there are so many different ways that this works. And that's kind of what happens when they create new formulas. You have to be able to prove it multiple ways. And so that's what we will go ahead and study this year, is you'll be doing processes like this where you solve it one way and then you check it using a different method. Okay, so it's just going to make you a lot stronger mathematically. Let's go ahead and do another one. This time, we are replacing the x with a 3. So our formula is f of 3 plus h minus f of 3 over h. So again, it's the same formula we've been using, but instead of an x, they gave us a numerical value. So the first thing we do is go ahead to the original function, change the x to 3 plus h. So it's 3 plus h quantity cubed minus the original function, but put in a 3. So 3 cubed. So let's go ahead and simplify the top. This means it's going to be kind of a pain in the butt, but this power of 3 means that I have this group 3 times. Now 3 cubed. 3 times 3 times 3 is 27. When I go to expand this, you can only FOIL 2 things at a time. So I'm going to, for now, just carry down the 3 plus h, FOIL these two. 3 times 3 is 9. 3 times h is 3h. 3 times h is 3h. 3h plus 3h is 6h. H times h is h squared. Go ahead, make sure that we still include that negative 27. I don't want to lose that in the process. Now I cannot FOIL these because this is 2 term by 3 terms. So step 1, I need to distribute the 3. 3 times 9 is 27. 3 times 6h is 18h. 3 times h squared is 3h squared. Now I distribute an h. 9 times h is 9h. H times 6h is 6h squared. H times h squared is h cubed, minus, I still have my 27. Now remember, if you go ahead and we expand this, this is the process where we should be able to cross things off. Here's a positive 27, here's a negative 27. I think that might be all I can cross off. Okay, that's all right, we got this. So if I go ahead and I combine my like terms, I have h cubed. This has 2 h's, this has 2 h's, so that's 9h squared. This has an h and this has an h. 18 plus 9 is 27h, all over h. So now you go to each term and you remove 1h. If I had 3 h's and I take one out, I'm down to 2. Plus 9. If I had 2 h's, I take one out, I'm down to 1. Plus 27h, the h's cancel, so you have 27. So here is your first part. You just simplified what's called the difference quotient. Now, as h approaches 0, this means the horizontal distance from 3 is approaching 0. You're coming in towards 3 from both the left and the right. If I put a 0 in here and a 0 in here, I'm going to get 27. So this is our limit, okay? We want to check it using the power method. So if I go ahead and I take x cubed, my derivative, the 3 comes out front, you rewrite the x. I had an exponent of 3. If I reduce it, now it's a 2. They want us to calculate the derivative if I have a 3. 3 times 3 squared. 3 squared is 9. 3 times 9 is 27. So we proved that the limit of this function, as x is approaching 3 from both the left and the right, the y value is approaching 27 from both directions. Okay, let's go ahead now. This time, it's just reviewing that you can use this just to find the derivative. When you have the number, you're approaching the limit, or you're finding the limit as your x value approaches that value. So coming in from the left and the right to the x value of 5, coming in from the left and the right to the x value that's a 3. The derivative is what we did before. I just want to make sure that you do see the difference. If it's a derivative, we leave it as an x. X plus h minus f of x over h. Okay, so this one's going to be a little bit tricky, but it's good. We want to challenge ourselves. Step 1, take all of the x's and put in x plus h. X plus h quantity squared plus 2, x plus h replaces the x plus 2. So that's this piece. Now minus f of x, that's the original. So x squared plus 2x plus 2. So I went ahead and that's what the top is. I need to expand this. X plus h squared is x plus h 2 times. So I can FOIL it. X times x is x squared. X times h and h times x. When I add them together, I would have 2xh's. H times h is h squared. I can distribute the 2, making it 2x plus 2h plus 2. Distribute the negative. Negative x squared minus 2x minus 2. Now when I look, I should be able to cross a whole lot of stuff off. Positive x squared, negative x squared. Positive 2, negative 2. Positive 2x, negative 2x. So what I have remaining is 2xh plus h squared plus 2h. Now I go ahead and put that h in the bottom. Go one term at a time and eliminate an h. H would cancel h, giving you 2x. Plus 2h's, take one out, I'm down to 1. Plus h would cancel h, leaving me with the 2. So that is the first part. When you're doing a derivative, you're saying the horizontal distance between the 2 points on a secant line is approaching 0. So the points are getting really, really close together to match the tangent line. So I'd have 2x plus 0 plus 2. That's 2x plus 2. So that's the derivative. Then to check it, you take the original function, and we have to go ahead and do the power rule. So I bring the 2 out front. You still have an x. This had 2 x's. If I take 1 out, I'm down to 1. Plus, this x technically has a 1. 1 times 2 is 2. There was 1x, so if I take 1 minus 1, there are no more x's, and the derivative of a constant is 0. So this shows that it should be 2x plus 2. This shows that it should be 2x plus 2. So again, just reminding you that you can also use this not only to find a limit based off of a number, but also to find a derivative. Okay, let's do one more. And again, today is all about stepping it up. So check out this beast. If I want to find the derivative of this, it's f of x plus h minus f of x over h. Okay, if you're finding a derivative, that's when it's x's. If you're finding a limit, that's when x is going to be a numerical value. So step 1, 1 over x is really x plus h, minus the original, which is 1 over x, and that's over h. Well, on the top, they want us to subtract fractions. You cannot subtract fractions unless you have a common denominator, and I cannot eliminate anything here. So my common denominator has to include both pieces, meaning it has to have both the x and the x plus h. So when I look at the first fraction had the x plus h, I need to multiply both top and bottom by x. That way I'll have the common denominator, 1 times x is x. Now here, the second fraction had the x. What that was missing is the x plus h. So I need to multiply both top and bottom by x plus h. Now here, 1 times anything, that's the multiplicative identity. If you multiply anything by 1, it keeps its identity. So this stays x plus h. When you are adding and subtracting fractions, your common denominator remains. So this is x times x plus h. On the top, you're subtracting like terms. X minus x, that cancels. This is like 0 h's because there's not an h here. 0h minus h is negative h. Now, that is the top all over h. Well, you can't divide fractions, so I keep the first fraction the same. Negative h over x times x plus h times. Now you go ahead, change divide to multiply, flip the second fraction upside down, which in this case happened to be an h. So I flipped it upside down. Now it is 1 over h. H cancels h. So it's negative 1 over x times x plus h. That's part 1. Now your derivative, as h approaches 0, as the horizontal distance between the points P and Q, as the horizontal distance gets less and less and less, you're approaching the tangent line. So I go ahead and I replace h with a 0. Well, this ends up being -1. X plus 0 is 0. X times x is x squared. So here is the derivative. Now, if I'm checking that, our function was 1 over x, which is the same thing as x to the negative first power. If I'm doing the derivative, the -1 comes out front. I keep the x. This was a -1. If I minus 1 more, it becomes a -2. You can't leave it like this because you have a negative exponent. This negative exponent goes to the x. So -1's on the top, x squared is on the bottom. So yes, we confirmed that we did the 3-step or the secant method to get the derivative. We confirmed that this is the correct derivative using the power method. Okay, last idea. I am a visual person, you know that, so I just want to make sure that we look at something before we jump into limits too far. You can have limits that approach positive and negative infinity. When that happens, we are looking at those horizontal asymptotes that we studied back in college algebra. Now remember, a horizontal asymptote, what that means is as your graph goes all the way to the right, all the way to infinity, it's going to be getting closer and closer to a value, but it won't actually touch it. It's kind of like it's playing that game lava. Okay, you get really close to it, but you're not going to touch it because then you'll get burnt. And so here, this says the limit as x approaches positive infinity. This means as you're going to the right, what happens is you're going to the right, notice that your graph keeps getting closer and closer and closer to 2. So it has a limit. That 2 is called your horizontal asymptote. That's the line that your graph is going to get really, really close to, but never actually touch. But it is still a limit because it's approaching 2. You might have a horizontal asymptote going to the left. If you look at this graph, as it's going to negative infinity, and that's what this means. As your x value is going all the way to the left, going to negative infinity, notice it's getting closer and closer and closer to the x-axis, but it's never touching it. But as you go to the left, it is approaching 0. So it is possible to have limits as you are approaching positive and negative infinity. What you're doing is you're looking for horizontal asymptotes. As you go all the way to the right or as you go all the way to the left, your graph is getting really, really close to, but not touching what value, whatever that value is, that is your limit. And that is the second part of 1.4. Hope you had a great day. Talk to you soon.